Welcome, everyone. This is January's Tech Talk. I'll do the quick intro because Mike is out for today. Today we have Guy here from NooBaa to talk about the NooBaa data platform for distributed hybrid clouds. The reason why we're talking about NooBaa and not a Ceph topic as we usually do, a couple of reasons. NooBaa was recently acquired by Red Hat and will be open source shortly. From my perspective, I'm interested in gauging the interest among Ceph community members, developers, users, vendors, in these sorts of hybrid multi-cloud capabilities that NooBaa provides. That guy's going to be talking about, and we're interested in looking at how those capabilities can be combined, integrated, and can complement RGW. I think the first step in that conversation is just to give everyone an understanding of what NooBaa is today and how it works. So I think Guy has a presentation prepared. He's going to go through it, and then of course feel free to ask questions. We're going to have some Q&A at the end, or feel free to interrupt partway through if there are any questions. So that, welcome Guy.
Thanks.
Your mic is not quite working though.
Still not good?
That's better. It was cutting out before.
So let me know if
That's a little bit better now. Let me mute you.
Okay. So I really hope I'm not gonna have major connection issues. If I do, stop me, and I'm going to share my screen as well because I want to show you the presentation and a demo. Sorry.
Okay.
Okay. Can you see? Is it good? Yeah? Okay. Okay. So, hi everyone. Thanks, Sage, for inviting me to talk at the Ceph Tech Talk. And I'm going to talk about NooBaa and what is NooBaa and what do we mean when we say a data platform for distributed hybrid cloud. And I'm going to show you a demo, and let me jump over to what I planned for today. And this is just suggested times, I guess. I don't have any problem with interruptions for questions, certainly during demo, but at any point. So I just kept just a few minutes at the end, but I'm sure I'm gonna make the first parts quicker than what I noted here. So I'm going to go through the market as we see it, what is our solution, show you the demo of how you can actually use NooBaa and what is the features that we're providing for this market, and just a short discussion on what's next. Okay. So quick introduction, myself and NooBaa. So I'm a software architect. I wasn't born this way, but I certainly have become a software architect, and I love software, and I've done that for a while. So I've done that in the Air Force and later on at Exanet. Exanet was a sort of a distributed or more of a clustered file system. You're hearing me okay? Just give me some note. Yeah, okay. Clustered file system was acquired by Dell, was later a fluid file system by Dell. And in recent years, I was at NooBaa. I founded NooBaa, and until 2 months ago, we were acquired by Red Hat, and I've joined Red Hat. And NooBaa's path was since 2014. When we started, the cloud was already there, but it was not the same. And we came from Exanet and Dell, where the cluster file systems were trying to make a dent in enterprises by clustering the file system together, and we actually thought there was a more burning problem there that we should solve, which is to connect stuff at a higher level. and this is where we start from. And actually, I don't know if that's surprising or not, but our first hire was a UX person, and she is still with us today, and she's doing a great job. I'm going to show you some of her some of the management and stuff, and we at retrospect we think it was the best choice we've made from product perspective. And just a little bit about the culture and what we believe in. So we promote flexibility to choose and change choices. Usability, because we really believe that things should first be usable before they are doing all the rest. And whiskey, of course. Okay, so I'm going to jump a little bit into the environment that we see today, and it was not exactly this way 2014, but it was there were seeds of this at that time, and we were thinking about this problem as well. So the problem for enterprises living in this world of on-premises and clouds is that it's distributed by nature, and the fact is that enterprises have too many applications, too many unknowns in their operation that pushes them to adopt all of the technologies almost, and they sometimes have a choice, but in many cases they don't, and the reason is that they might think that they can enforce something, and then they do an M&A, and suddenly they bring into the enterprise a completely new infrastructure, and they have two of these, and each of these are different, separated. In the best case, they might have a one-to-one connection, so you can do stuff, copy stuff from one another, or read stuff from one another. But in most cases, there is there's nothing overseeing all of these infrastructures and providing a platform for data management. And this is something that we've seen, for example, just as sort of big examples. So Google were acquired Waze, was a long time ago already, but for a long time, and I think still today, Waze is still using AWS, and it's actually a very painful move. It's really hard to make the change, and the status quo is that they actually need to live in this environment. And there's a bunch of examples, and in some other cases, it's not forced, but it's actually something that they would like to do to reduce risk, to use new technologies that are available on one environment and not on the other, and still maintain connection with their existing applications. And that's basically the market as we saw it. And in this sort of a big picture problem, there are multiple. So in big picture, there's multiple problems. There's the compute side of it. There's migrations. There's multiple things. And what we were set to solve, was to provide a data platform. Initially, at this point, also for unstructured data. And let me jump to the next slide, and I'm going to show you a little bit of the solution. It's a big slide. I'll take you through it. One second. So we are actually creating a flexible data service, and by that, what I mean is that we wrap multiple resources that can be consumed either through an API or directly from a local resource, local file system, whatever that is. It can be on-premises, multiple data centers, clouds. And for the application, we provide endpoints that abstract the location and all the values that I'm going to go into right here, so that it's transparent to the application, and still each of these repositories containing data can have completely different properties, can have different location, different resources, different performance characteristic that the platform will provide. And the access protocols, S3 and Lambda, are providing the service. So just to go a little bit through what is provided here. So the load stack, the storage stack, I'm not going to go into much because I think we can jump to the data services quicker, and you're going to see it if needed. So on the data service side, so a few things to note. So first of all, by providing an API, an S3 API to the application, we're using endpoints and abstracting the location, we can provide an active access to data at all times. So even if there's a change, we want to insert a new cloud into the platform, or remove a cloud from the platform, add a new on-prem resource, burst in the cloud, whatever the use case is, data is active at all times using the existing resources that is being the data is available at the point of access. And in the next step, we will optimize for the next access, locality, whatever. Next point is flexibility, so that we provide an easy way of adding any resource from cloud, any resource on-prem. We can support Linux or Windows hosts. We support AWS, Google, Azure, and a bunch of S3, any S3 compatible, but also we have a pluggable way of adding, easily adding more backends for connecting into services for storage. And this allows, and also the other point on flexibility is that we have a sort of I would say a fine-grained control over how we map data onto storage resources, so that we can coexist. We can have all the data. Each portion of the data can have a different status of where it is located, and so that we can change it on the fly. And from the application perspective, it's completely transparent. Next point, we support Lambda as an API, but not just by invoking Lambdas on Lambda services, which is consumed outside of the platform, but actually we support it in the platform. We implemented that because we saw that as a core feature for data services. And this allows us to very quickly install a function, extend the platform to do something new, and actually have a data-driven platform, so that we can trigger specific functions from data events. So an object creation, object deletion can trigger functions and do manipulations and do whatever is needed to create a personalized platform. In other cases, we also use that to solve immediate requirements in the field, which is super useful, and the reaction time using that is immediate. So you have a platform, the customer suddenly wants something new, and you just put a function into the existing platform. No time, takes no time to do that, and it's already providing new functionality. And last is security. So we have a secure, so always secure model, so that the data is always secure, rest and transit. So I'm going to go to the next slide. I'm going to go through that flow of how we actually ingest an object into the platform, and just to give you a sense of what's going on and how that behaves. And I think it will also help with the architecture and demo, so I think that's a good preview. It's short. So when an application connects to the S3 endpoint and puts an object, say the Mona Lisa picture here, so that we pass it through this pipeline of ingest, and this pipeline is fragmenting the objects into variable size chunks, so that we can actually look for dupes, but in a variable way. So if there's changes in push or sort of a pushed bytes, pushed objects in the internal to the object, it will detect that, and it will find dupes, remove them at the endpoint level, so that we don't have to ingest that over network to storage nodes, compress each chunk, and encrypt it. And in the last phase, we actually look for storage locations which are most optimized for that specific object according to that data repository that we are serving, and the object type and sizes, whatever. And we can store each of these in a different location as an encrypted chunk. And the encryption keys are stored separately from the chunk itself, and so that there's also an opportunity to support regulated environments that require encryption with separation. And in this layer, we also support replication, erasure coding, and whatever the storage resiliency is configured. Okay. Now I'm going to go over the system components here. And before that, if any questions, feel free to interrupt. So I'm going to describe briefly the components of the system here. Each of these is a software component that we package together for easy delivery as a VM image, and it can be also extracted from that VM image to scale out, to further to add more endpoints or daemons, and cluster the NooBaa core to create more resiliency and scale. But let me start from the beginning. So an application host is connecting to a NooBaa endpoint through S3 or Lambda API. And the endpoint is responsible for doing all of the protocol stuff, authentication, whatever. And it also handles all of the chunking, dedupe, compression, encryption. So all of the network and CPU sort of tasks that requires scale out. And the reason is for doing all of these at this point is that we created the endpoint as a stateless component that can be scaled out seamlessly without any effect on the rest of the system, and it does not have any state. It can communicate directly with the NooBaa core right here, and live in a world where it doesn't need to know anything else besides where's my core. And the application sends the data and retrieve data from the endpoint directly. And the endpoint, once it has the encrypted chunks ready, it communicates metadata to the core. We also refer to it sometimes as brain, because it's very smart. And the response is basically instructions. So the brain is responsible for like a nervous system, just sending instructions and making decisions, making conscious decisions about the state of the system, what should be done, what is the policy, what is the most optimized flow of actions for every operation. And by making that per every operation, we can actually make very smart decisions. So we can say, okay, now you need to store that on this bucket in the cloud. Now you need to store it on 2 buckets in the cloud. You need to store it on one of them, and we will replicate one later on to the second one. And you can use a hybrid model when you have first you store on local daemons, and then we will in the background replicate it to the cloud, etc. So all of these policies are controlled by the brain. Yeah. Let me jump a little bit to the cloud resources. So we support, as I said, S3 compatible, Azure Blob, Google Cloud, and actually adding more is very simple. It's not it does not require a lot of implementation, just require sort of a key value implementation, roughly, so that you can plug in anything that can provide a key value and refer to it as a new storage, as a new resource, basically. And also these daemons are actually storing key values, and they use a file system for that, so they store encrypted chunks on their local file systems. In addition to that, these can also be used to run Lambda functions, so they can host sort of a function node. It can invoke functions internally. And for that, and for the storage part, we'll monitor the hosts. We know their performance, CPU utilization over time, and capacity, and we communicate all of this information to the brain periodically so that it has a concrete view of the system and its status. And at every point of time, the core can make these decisions to optimize all of these parameters of of the operation of the system. So these are the components. Just a note on delivery, we package everything together as a VM so that you have, when you just launch the NooBaa VM, you have everything working together. You don't need to install anything outside yet, so that only when you choose to scale, you actually need to install these components on new VMs or contain whatever the infrastructure is, and when you scale it, you get more capacity, more CPUs, more memory, more network. Okay. So I think it's a good time to show you the demo. Just before I'm jumping into the demo. Sorry. Huh? Yeah. Any questions? Just jump in. So before jumping to the live system, I just want to say some words about deployment. So I've said it already. You download a VM, you run it either on your laptop in a virtual VBox or any hypervisor from the marketplaces of AWS, Azure, Google, on KVM, wherever you need to. ESX, VMware, of course. So you download VM, you run it, you give it an IP, and connect to the web console. And from that point on, every interaction is provided through the web console. You can do stuff with CLI, but we actually think that CLI comes second in that onboarding, and first you use the interface. Okay, so let me jump to that. Oops, let me go back, sorry. Yeah. Okay, I'm gonna zoom a little bit. I hope you can see my entire screen. If there's problems, tell me. Okay, so first step, you have your system running after deploying on a VM. The first thing you should do, in any case, is connect your application. And you want to test the application against the endpoint. You want to see that it works. You want to see that that you can make it run exactly like you want to. And you don't need to add more storage yet. because we have internal storage inside the core that we handle automatically once you scale, and we can get the data out of it automatically. So you connect your application to this endpoint. These are the credentials, and of course there's more users, so you can get whatever credentials you want to for your specific access. And you can test it. You can test the application, whether Commvault, whether it's Hadoop, whatever your application is doing, and CyberDuck, whatever it is. And now, let me show you what's going up next. So you connect your application. You've written a few objects. You've read it. It works. Perfect. Now the next step is to see where the services are actually managed and to scale and get the next steps of managing a system. So let me jump to the buckets, and I'm going to show you the movies bucket just for a second here. And this is where we manage everything about the data services. Those policies here, those triggers, I'm going to show you a little bit. So first of all, there's the data placement piece. Let me move my face. Okay. So every bucket can have a different policy for data placement. You can you can choose the specific resource that best that is best for this specific data repository for this bucket, and you can actually edit that on the fly and change, and the data is always active through any transition. So let me show you a little bit. We can support either mirroring between multiple resources, so that you can, for example, have a multi-cloud environment just by choosing both AWS and Azure. You can have a multi-region replication, and you can have an hybrid one with either of the data center pools, which is a group of NooBaa daemons. And for other cases, you might choose to spread it because you want to aggregate, for example, multiple data centers which are close by, or just for bursting into new infrastructure when there's new projects, new capacity needed. So any change of these can be just created on the fly. So here's how I just go to a single data center, London, remove the cloud, and I just declouded, basically, and updated the policy. Should be updated, and the objects of this bucket will change the policy in the background. We can also have visibility here. You can actually see we have 3 replicas, but there's one to be removed on the cloud. Okay, and it will, of course, update once the background task is completed. So that's data placement. You can control quickly where you want to place your data. We also support regions for locality. So if you put multiple regions and each of these have different locality, we can actually detect from which endpoint you write or read, and our NooBaa core responds with instructions to the endpoint to optimize locality and use the local resource first for writing, for reading, etc. So there's a bunch of things that is not visible as policies, but is implemented behind the scenes for optimizations. Data resiliency, you can easily choose whatever policy you see fit for this type of data. If you want less resiliency, you can change even from 3 replicas to 2, whatever you want. You can just see the effect on failure tolerance and rebuilding effort, etc. If you want range coding, just go ahead and define what you like. Okay. Object versioning, this is an API feature. Spillover is another service that can be enabled. If you'd like to edit spillover, you can create a spillover pool for this bucket that once the capacity is completely consumed, this resource will be used for any access usage. And once capacity is added to the sort of regular resources, it will spill back automatically. And the bucket quota is again just for limiting usage. Okay, so you've got basically through these services the ability to choose your locations, change them whenever you need, decide on resiliency or just use the default, of course, and use spillover whenever needed. And you can create multi-cloud environments with this, hybrid, and adjust according to your cloud strategy and plans. Now, next very cool thing that I want to show you is how you can connect between data and functions. So the platform is hosting functions, and these functions are connected, can be connected to buckets. So I will go back to a bucket called first bucket, which is the first of its name. And I'm going to jump to this view of triggers. Now this bucket is configured to trigger the mask credit card function on object creation on every log file. So what this means is that every object upload that completes will trigger this function. And let me jump to this function. And maybe I can push some stuff into it. I don't know if we have already. Probably do have some stuff, but I want to probably first. Yeah, so in background, I'll try to just push something here. Yeah, we have some copies here of logs. So you can see that whatever a log file lands on this bucket, we actually create a copy of it without with the credit card masked, basically, I think on a different bucket actually. And this function you can actually see the code. The code is just here. You can edit it. This is how credit card can be detected and masked, and it's as simple as a few lines of code. And it runs in Node.js, and it accesses the data directly. So the function can actually access data from the S3 API as well, just easily. Doesn't need to provide any credentials or anything. It just has credentials through the trigger, so that everything is already set up to run these flows. And you can have as many as you want. Some of these functions, so I guess just to give some sense, some of these are sort of data flows or data-driven flows that answer to some business need or functionality. Some of them is extended functionality, and some of them is exposing an API. For example, using Lambda is actually an API which is authenticated using the same methods of signatures and whatever, and you can use it to consume APIs from the system. And we have a bunch of examples that we're adding sort of functions to expose APIs. It's really easy. It's really simple, and it can do some stuff on the background on the sort of way to the API, to the internal API. And this gives a very cool level of flexibility to a running system that needs something extra. Any questions so far?
Do you have some other examples of what kinds of triggers you might do besides the credit card masking, just to get a sense of what scope is there.
Yeah. So another example. So there's anonymization. There's tier. So there's one of the examples that we were given is, so someone wanted sort of a bronze, silver, gold tiering model, which means that you'd have sort of a three-tier and a life cycle. So after 30 days of gold, you're being demoted to silver, and after, for example, another 30 days, you're being demoted to bronze. So in order to answer to every, there's a sort of a very wide variety of ways a customer can describe its needs, and we got this requirement and said, well, we're not going to, invest heavy development in every kind of requirement like this and optimizing it to the fine level of perfection before we know there's a business and before we know the customer is happy with what the customer defined. So the case is that customers sometimes define it, but once they get it, they understand they need something else. So the point is that we created this tiering model here, and we created it with a function. So there's okay, so it calls another function. So let me do that. But this is, by the way, another thing that can happen. You can just it's actually functions. They can call each other, and it's not hard to do. Yeah. So that this function will take 3 buckets and actually detect the objects that should be that should move between each of these tiers, and actually make the transition between them. Okay. So these are sort of custom data flows, right? So you can create these on the fly for any kind of requirement that you bump into, and you can react immediately. You don't need to say, okay, so I don't have it. Yeah, I do have it. I need like 2 hours, and I can even test it, and there you go. It works. Does that answer your question?
Yeah. Thanks.
Okay. So there's a bunch of things here. I didn't show you everything. I think I'm gonna just show you just the things that you might be interested in. There's resource management here. You can manage every resource, add any connection to cloud. You can monitor the usage of the internal storage, which is limited for the POC stage before scaling to cloud or nodes. And you can create anything you'd like here to create the pools, groups, and stuff. And something else, regions, is interesting. It allows us to do locality optimizations of data access and decide where the operation should go first, where it should go second, and we can even decide on how to promote data to a local region in such cases as well. Clustering of the NooBaa core, management functions, account management, etc., etc. And the nice thing maybe to play around with is analytics. It's still beta, so it's not open in the last release without a small tweak, but it's cool. It monitors egress from every provider, so you can actually see what's your egress, and it's pretty nice, I guess, to monitor what you're actually doing in the platform, and how did your choices and the platform optimizations performed. Yeah, auditing. yeah, events, whatever, and alerts. And I think that's a good place to stop, I guess, the demo, and without drilling down to further stuff and going back to wrapping up the presentation. So, okay, so just before I jump on that, so the platform is very easy to onboard. That's a key thing that we wanted to create here, and it takes very little effort. It doesn't require any knowledge of the platform to start using it, um, and it provides multiple values to multiple use cases, and it can connect to many things. So even without further things that I'm going to talk now about what's next, there's a bunch of things you can connect it to. Cloud services, any compatible S3 and local file systems, etc. Okay, so what's next? So we're going to open source the platform at Red Hat, and we're very excited about it. And we think it's going to do very good to the platform because we think it's very extendable, and we think there's a lot of things that it doesn't do now that it should, and we made sure that the architecture is ready to extend it, and we will put a lot of effort to make it documented in a level that does not require us in the process for that, and we'll open source that and hope for a lot of users and contributions and value. We really want people to use it and get value out of it. So that's open source. The efforts we are currently chasing in the near, medium near future is containerizing, and for us, it's actually something that is quite. I don't know. It's not heavy lifting. We are running inside of VM today, but everything is not. It is very decoupled from the OS, the platform. We don't have any dependencies specific to the OS. So moving to to containers is not a big thing. However, we think that that's a good place to be. We think it's flexible and it suits the cloud model of orchestration. So that's first. We are chasing OpenShift and Ceph integrations. So we are trying to get into better integrations other than just connecting to S3 with Ceph and OpenShift. So containers will be deployed on to OpenShift, and we are still looking at how Ceph can actually how NooBaa can actually be added with Ceph in a more performant way and more valuable way for the Ceph use cases. And last thing is federation. There's a lot of effort from Red Hat and the Kubernetes OpenShift community on federation, and actually in that space we have a lot of connection with, so we are aligned with federation because we aggregate things wherever they are and can present a single API, single endpoint to the federated applications. So I think in that space we really are looking for opportunities to show use cases of federation and get better integrations. That's about it for the short term, and we are actually just sort of ending note, we are looking for an open community, so we're providing the latest VM on our website on download page, that you can download and just play with it. It's completely open for anybody to play with and provide feedback or not, and that's about it. You don't need anything besides VBox on your laptop or whatever you want. And we also have we're trying to build some interest from community, so we want to see who's interested and what is the interest, so you can jump on the community page and let us know. And my presentation is over. I think I have some time. Yeah, I have some time for questions, or I can jump back to anything. Yeah, feel free to jump in.
Yeah, I'm wondering if do the NooBaa policies support stuff like cloud arbitrage, where you can migrate based on shifting economics?
Yeah, so that's a good question. We actually got it quite a few times, and the short answer is no, and the long answer is I think it's possible to I think it's possible to create it quite easily, but I don't think we've seen the use case enough to to make an arbitrage system out of it. I think that arbitrage is still sort of a thing that doesn't really materialize yet. So the changes in prices are not real time, and it's more of a constant thing. I can go on, but I think I think it's a good thing once there's a case. I think economy is a thing that should be optimized further in the platform. To date, we optimize mainly the heavy economy considerations such as egress and so bandwidth, basically, right? This is, for example, the egress view.
I can jump in with a couple comments.
Yeah.
Again, feel free to interrupt me if anybody has questions. So I think that from the Ceph perspective, this NooBaa is interesting because it's a lot of the same capabilities that we're driving towards adding to Rados Gateway. So RGW today has a federation capability that lets you replicate across sites. We're in the process of adding the ability to back RGW buckets by existing clouds, so you could tier to S3 or tier to other clusters. Our users today are mostly on-premise, but most of them either have or are planning to have multiple sites, and so these sort of multi-site policies are really important. Where do you want to put the data? Where do you want to move it? Can you change that in real time? Can you change it on a per bucket basis? These users are enterprises that have footprints, across private data centers, across public clouds, and the ability to flexibly make use of all those resources is important. So sort of in the hand wavy ideal future, it would be great if the Rados gateway and the NooBaa gateway were just the same gateway. There was one gateway that just gave you everything that both have to offer. The scale out storage on premise and the flexibility of consuming public cloud storage and so on. These are two separate projects that didn't evolve and weren't designed to integrate. So there are a lot of technical questions and challenges about how that could happen. But I think the first, I think, piece for me is to understand the extent to which the community, the Ceph community, is interested in these types of capabilities and how important it is to provide them, and whether you know traditionally Ceph has focused on just storing lots of data at scale on your own hardware, the traditional sort of software-defined storage. And NooBaa is really positioned sort of one layer above that in terms of managing data across different sites and defining policy, and whether sort of in general, the Ceph community is interested in like expanding its scope to include these types of capabilities. So I'm interested in hearing comments or questions about any and all of that, either now or we can kick off an email list discussion or whatever.
Yeah, me too.
Yeah. Any thoughts from the room? But for what it's worth, the most recent, talk I've been giving for Ceph at various conferences has been about these basic sets of capabilities. Not just for Radius Gateway and object storage, but also for multi-cluster, multi-cloud capabilities for block and for file, and sort of how organizations should be able to manage their data across different sites, and what we're doing in Ceph to sort of enable that. I think object is particularly interesting because the way that the APIs are structured and the way that they're used makes it like much more amenable to having multi-site active, concurrent access, and dynamically moving data around. Just the consistency model and so on makes it much simpler to actually implement.
Yeah. One of the things I've been hearing from at least Reddit people lately is that there's there's a thought that migrating the block storage, so the block volumes, should be done through an object API. So I think that, so not migrating, I mean either multi-site federation, whatever the use case is specifically, and it's interesting on how how the guys actually using these migrations view this. So what will be the process, right? So
Yeah.
okay, so you push that to an object and then pull it from the other side. That's perfect, but you need to saw this as a functionality that works, I guess.
Yep. Yeah, I think one of the things that I keep coming back to is that it's really not just a storage problem or a data services problem. The migrating data and controlling placement and so forth. It's really about controlling the applications that are consuming and generating the data at the same time. And that's part of the reason why we're super interested in the containerization part and integrating with Kubernetes and OpenShift, because that's a platform that gives you sort of a single control point to control both the storage and where the data is going, and how it's managed, and also the applications that are consuming it. So you can orchestrate the movement of applications between, lift up your whole infrastructure between two public clouds, for example, and in theory, at least automate the whole thing. Yeah, there's a lot of pieces, and how you do that with object and how you do it with block and how you do it with file are all a little bit different, naturally. Yeah. Okay. If there aren't any other questions, we can wrap this up. I'd like to kick off a thread on the Ceph development Ceph users list also to discuss this. So we'll probably get more feedback there too, but we can reference this.
Yeah, great. So we'll be we'll be happy to discuss and get some discussion going on. Hey guys, thank you very much.
All right. Thanks, everyone. Thanks, Kai.
Have a nice day. Bye bye.
Take care. Bye.
Bye.
Thank you.